of Robert and Loretta. Robert is the software engineer at Cloudera. He is a BPMC member for Oozie. And Loretta is the software engineer at Yahoo, and he is also the committer for Oozie. So they're going to talk to you about the work they have done for the high availability in the Oozie. To learn more about that, please welcome Robert and Loretta.
Okay. So basically we're going to talk about what availability is, and then go through an architectural overview, and look at some security and authentication issues we ran into, as well as H-catalog integration and other challenges that we had with HA. So for those of you who don't know, Oozie is the workflow engine that runs on top of Hadoop, and it has integration with Pig and MapReduce and Hive and all of those things, and also lets you schedule jobs. For our purposes, the important thing to remember is that it runs as a server, and you submit jobs to it. So high availability is a system that has non-planned downtime, even if something fails. So if the Oozie server crashes, users should still be able to use Oozie. And you usually do something like that by adding redundancies and removing single points of failure. And on top of that, we had some extra goals of trying to make this as transparent as possible to the user. They don't even have to necessarily know that they're using an HA-enabled Oozie server. So to do that, we didn't want to change the API in any drastic ways. Right? So the first part of this architectural overview is how we talk to the database. So most of the Oozie state is inside of a database, and that includes like the submitted jobs, the workflow definitions, current status of the jobs, all of that is in a database. So what we opted to do was active-active availability, which means that you have multiple Oozie servers all running like normal Oozie servers. So you can actually send requests to submit jobs or retrieve information to any of the servers. And they all talk to the same database, so they all have the same information. That's in contrast to the active standby model that like the name node would have, where you have an active name node and a standby name node, and only the active name node is actually doing anything. When you have a problem with the active name node, it switches to the standby name node, which becomes active. So here you have all active servers. From this, you also get horizontal scalability, which means that if you want more Oozie processing power, you just have more Oozie servers. So for making sure that different threads in an Oozie server don't process the same job at the same time and conflict with each other, we used in-memory locks. For HA, we have to extend that now to multiple Oozie servers. So we use Zookeeper and have the locks now in Zookeeper. And that prevents an Oozie server from processing a specific job on multiple servers at the same time. And that's important because the jobs are not actually assigned to specific servers. They can run on different servers at different times. And that's actually something pretty common that will happen. So here's basically just a very simple diagram of 3 Oozie servers talking to a database, which also should be HA, because you don't want that to now be a single point of failure. The next part of the architectural overview is how you talk to Oozie. Everything goes through a REST API normally, and that includes like the web UI, the Oozie client, even the Java API ultimately goes through REST, and any other programs that users have written or queue or whatever. So those things are all expecting to have a single entry point that they can talk to. So they don't know how to talk to multiple addresses. So to allow for that, we put in front of the Oozie servers a load balancer or a virtual IP address or a DNS round robin. And then basically the client would talk to the load balancer, which would then just choose one of the Oozie servers. And that technically should also be highly available. So here's just a diagram of that. The user talks to the load balancer, which as far as they know is just another Oozie server. And then it just chooses random Oozie server to talk to in the background. The next part of this is the log streaming feature. So you can ask Oozie for the logs for a specific job. And those are obviously not in the database. They're in the log file in the local file system of the Oozie server. So each Oozie server only has access to its own logs. And as I said before, jobs can be, be processed by different Oozie servers at different times. So the logs for that job can actually be spread out across multiple servers. And so if you ask some Oozie server for logs, you're going to have to actually get them from all the other servers. So the way we handle that is the Oozie server does it for you, so that the API is the same as far as you're concerned. And that looks like this diagram where the load balancer pointed them at the bottom Oozie server, and it's asking the other two Oozie servers for any logs that they may have for this job. And it will then collate them together and send them back to the user as one set of log messages. So as far as the user is concerned, it looks exactly the same as non-agent. And it just uses the same API that the user is using, so there's no new calls here. And you may realize there's a small issue here. Is let's say one of the servers is down like the middle one or something, and you wanted to get logs, it's not going to be able to find them now. So the log streaming is sort of more of a best effort action, because that's sort of a tricky problem that we're still trying to figure out a better solution for. Another thing I wanted to talk about was security. All the existing security features that Oozie has, like Kerberos and SSL and everything, they all still work basically the same as they did before. Something that was sort of a problem was authentication tokens. So when you talk to the Oozie server with Kerberos, we give you back a cookie that you can use instead of Kerberos. And the main reason for doing that is it puts less load on Kerberos and reduces a lot of the overhead. The cookie is a lot smaller. So these cookies are signed so that you can't just create your own cookie. And that's usually using a randomly generated secret for the signature. So if you have multiple Oozie servers, each with their own randomly generated secret, they won't accept cookies that were generated by other Oozie servers. So Oozie's using Hadoop Auth for all of this. So in Hadoop 2.6, we've added support for pluggable secret providers. And what basically that means is if you can make your own implementation of code that will generate the secret that Hadoop Auth should use for this. And also we added support for rolling secrets, so the secret can actually change over time. So we added a Zookeeper-backed implementation that has a znode that stores all the current secrets in the next secret. It synchronizes between all the Oozie servers, and it also rolls. So that's if you had just a static secret, then it's going to stay there for quite a long time, and possibly someone could guess it. But this, by rolling it, it's a lot more secure, and it's going to continue. There's a lot of details in how that actually works. I'm just going to talk at a very high level on how the next secret is generated. So in this case, we have 3 Oozie servers. They each want to do a different next secret. They just randomly generate one. In this example, I just used simple secrets, so it's easy to talk about. We have A, B, and C. They all try to write the secret at roughly the same time to the same znode in Zookeeper, and they use the same version number so that only one of them is going to succeed, and that's the property of Zookeeper. So it doesn't actually matter which one succeeds, because it's all just a random string anyways. So they're all going to try to write this, and one will succeed, the others will fail, and then they're all going to try to read from that znode. So when that happens, let's say the first one succeeded, we're all going to read back the same secret, and then we'll use that the next time they roll over. And so that way we synchronize the rolling the random secret without having to do any locking, and without having to have any sort of election for the leader to choose the secret for us. It's more of a democratic kind of first come, first served. So now I'm going to hand it to Diana.
Yeah, please.
Hi, so yeah, let me take over the presentation. So I'm going to start with the authentication. This kind of slide kind of explained at the high level architecture about how each component interact with each other. So the in the HA, we start to have more than one Oozie servers. And as Robert mentioned at the log streaming, that the Oozie server has to talk with each other. Also that those, each Oozie server has to access Zookeeper for those distributed logs or some other purposes. And yeah, so basically, and also this server has to talk with Hadoop clusters. So all those interaction, has to come with authentication, and pretty much we are using Kerberos for the those interactions. So between Oozie server and the Zookeeper, using Kerberos, and between user and Oozie servers in the HA setting, I think there could be multiple way of basically setting those HA, but for example, the Yahoo setting, we have those load balancer in the middle between the user and Oozie server. And we also support those Kerberos, but also that each company tend to have its own implementation of a cookie-based authentication. So, for example, the Yahoo case that we have some mechanism for the bouncer, and between user and the Oozie servers, we can plug in those cookie-based authentication. But that is even true even before those HA. And I'm going to talk about a couple of other technical challenges in the HA. One thing is H-catalog integration. That even before HA, Oozie already integrated with H-catalog. In case you don't know about H-catalog, this is kind of a hybrid meta store. So metadata management service for the HDFS data sets. And one good thing about H-catalog is that they can publish notification when data registered to the H-catalog. And then Oozie can consume those notifications through JMS, messaging service, just like ActiveMQ or some other RabbitMQ or those implementations. And because of this, Oozie can start workflow job immediately after data becomes ready. So we used to basically just calling those HDFS, and those calling interval somehow that adds up to some latency. But some job basically is required a very low latency and they're serial sensitive. So this mechanism kind of help that kind of job. And this is how it works. So when let's say that the job is running on the Oozie server 1, and Oozie basically asks H-catalog whether data partition this particular job is waiting for exists or not. And if it doesn't exist, and then register the topic to the JMS, and indicating that I'm becoming subscriber of this topic. And then H-catalog, when data register to the H-catalog, push notification to JMS. And JMS basically broadcasts notification to the all subscribers. So then Oozie can start the job.
I think that's perfect.
Sorry. And then this basically has a unique, technical challenge when we apply this to the HA. So to support those H-catalog integrations, each Oozie server kind of has in-memory data structures. That data structure store list of the job waiting for the particular data partitions, such that once notification comes in, Oozie immediately know that okay, those are the list of the job ready to go. But in the HA setting, we have to kind of keep consistent, keep those memory structure consistent. Meaning that in the HA, job may start on the Oozie server A, Oozie server 1, but in the middle can migrate to other Oozie server if the other Oozie server is down. So in that case, basically the Oozie server 2 has to update those in-memory data structure. Also that, like this case, let's say job started on the Oozie 1, but later on migrate to the Oozie 2. In that case, in order to receive notification, Oozie server 2 has to create a topic listener for the JMS. And later on, that we also there are some cases that Oozie server has to clean up topic listener, which is no longer needed. And other challenges in the HA. One of those is SLA support. So Oozie have functionality to monitor those SLA. So the user can specify that, okay, this job should start this time, duration is this much, and it should end by this time. And if the job kind of delay and doesn't start or doesn't end, at those specified time, and then send a notification. And in order to do that, Oozie has in-memory data structure to kind of keep track of the SLA status for each job. And that includes that, whether notification is sent or what is those start time or end time, those kind of information. And then each Oozie server kind of keeps those in-memory data structure and then kind of iterate through the data structure to check job status. But in the HA setting, that each Oozie server does this SLA operations. So to avoid sending a duplicated SLA message or avoid missing those SLA message, we have to sometimes kind of check those source of truth, which is database. So we have to add some kind of safety check against database. Also, that the multiple server, Oozie server, could update the status on the same job. And so we have to kind of use Zookeeper to synchronize this update. And the other challenge is that distributed locks. So in a way that the Oozie is designed, there are several cases where one thread has to acquire the lock several times. So lock has to be the entrant lock, and in the HA setting has to be distributed lock. So we provide this re-entrant distributed lock using Apache Curator and the Zookeeper. And the other challenge is distributed job ID. So in the Oozie server kind of keep sequence number for the job ID, and every time new job submitted, and we increment those numbers. But in the HA setting, if each Oozie server keep different sequence number, what's going to happen is that when the user look at those all jobs submitted from all Oozie servers in the one UI, job ID is going to be out of order. So that's why we have to kind of maintain that one sequence number for the job ID, which is shared by multiple Oozie servers. And but this is not as easy as it sounds, because those sequence ID, just look at those sequence ID and increment it. That operation has to be atomic. Also, that currently that the Oozie has to support kind of a good level of scalability, because we have a lot of submissions, and so we kind of solve the several performance issues around that one. And the other item is Zookeeper failure handling. So in the HA, Zookeeper plays very essential role. So this is a rare event that the Zookeeper comes down, but once that happens, ideally Oozie server should automatically shut down, and then not accept any more job submission. And kind of we added the mechanisms to automatically shut down the Oozie server, and those by monitoring those Zookeeper's status. Also that actually I forgot to mention here, but we also have share leave functionality in the Oozie. Oozie kind of provide those shared library concept, which is that right now that pick jar, hive jar, and some other jar, users have to upload those jar by themselves. But we can have some shared storage on the HDFS which stores those libraries, and user can consume those libraries from the central locations. And those, to support the share leave, we have to kind of, and every time some change happens in the share leave, we have to basically issue some admin command to update the share leave. But just like a log streaming, that the user just access to the one Oozie server, but that admin command has to propagate to the other Oozie servers. So that part is also kind of a big chunk of the work which done by community. So future work. So learn from experience. In the Yahoo, we already deploy HA in a non-production grid and running more than 1 month. And we expect to deploy on the production grid in Q4. So it's going to be fun time, and we will probably learn from that experience. And the other item is the faster job failover. So currently, each Oozie server running one thread called recovery service, which is kind of peak non-progressing job every few minutes. And for the job failover, we kind of rely on this service. This interval is configurable, but normally that it is kind of a minute level. But meaning that when the one Oozie server is down, those failover takes more than a minute. Ideally, the Oozie server should immediately notice that when other server is down and then fail over the job. So one way of doing that is to use a Zookeeper Watcher, but actually community is working on this one right now. Also, last item is improve log streaming. I think Robert already explained this item. So current log streaming, it's kind of best effort, and when the server is down, we cannot get the log information stored on that server. So so we are kind of trying to improve that one. Yeah, and this is kind of end of last slide, and last but not least, but this HA work is kind of community collective effort. And so kind of big thanks to the community to make this happen. So I think we can take a couple of questions.
Thanks for that. Just one small question, like for the HA for the logs, particularly, there's no thought of using BRDB or anything like that?
Without using what?
BRDB for disk replication so that you don't miss the logs. So there was a particular slide that you said you couldn't find the logs.
Yeah, I mean, there's talk upstream about a couple different ideas, including like some kind of shared storage thing or putting them in HDFS. But that's still something that we're working with. I think someone put up a proposal recently, but I haven't had a chance to.
Any other questions?
How did you test this, or more specifically, how do you simulate the various failure modes you're planning to do?
So I know that we have some tests where we randomly kill Oozie servers as they're running a bunch of jobs, and then check if the jobs actually finish at the end.
In our case, that we kind of using two servers and then just randomly kind of bring down the cluster to see what it is. So, yeah, pretty much same with Cerebral. Yeah, we are not really testing those kind of big scale which is setting like 5 servers, 10 servers yet. More like just we operating like 2 servers situation. So we just bring down one server.
Any other questions?
Thanks. Hi. So typically, the Oozie server's internal database is MySQL or Derrick, a very lightweight footprint, right? So now, given this HA initiative, actually, the database itself has to be HA, right? So now, what are the recommended databases available? And actually, preferably they should be running on other servers, right? On other hosts, not necessarily on the server that's hosting the Oozie server itself, right?
Right. So talking about this Yahoo setting, in the production we are using Oracle database. So we are not allowed to use MySQL and all that. So we have those DBA to manage those the Oracle database. And Oracle database side, that they have their own redundancy like rack servers. So yeah, so basically we are operating on both of them.
Right, thanks.
Any other questions?
Essentially, when you were talking about horizontal scaling, so this, so when you were talking about horizontal scaling, so with your round robin or whatnot, multiple Oozie servers, we can submit kind of more jobs and whatnot, but on the other end, we have just one job tracker or just one resource manager. So anyway, on the other end, it's not going to be scaling horizontal. So how much data does it really store in Oozie server or database for the Oozie server? So it really justifies running, for example, multiple Oozie servers. So it would, because again, on the other end, there is no horizontal scaling.
Well, I mean, so you can actually run Oozie against multiple Yarn clusters or Hadoop clusters. So you can have, half the job submitting to one job tracker and half to the other job tracker. And you also, I think, Hadoop, at least Yarn scales a lot more than the job tracker Hadoop 1. So I think that level, that number of jobs you could do.
Yeah. So yeah, actually, that from our experiments, we don't really have hit the limit about the scalability, especially those data size. And actually, initially that we had some issue because database kind of access to the database was not optimized, or some database from type. Like we are using a lot of growth and all that, but we are just rebuilding it. So so far, actually, so far so good. Yeah, in the future we expect probably some limitation, but yeah.
Yeah, just to add to there were a lot of scale questions, so just to add to at what scale Oozie runs. Some of our single clusters would, let's say, run 200,000 jobs a day, and 60% of those jobs would be Oozie. So if you aggregate over multiple data centers, multiple clusters, it's almost 1 million jobs a day. And again, 60% of that is Oozie. So far so good. As Rayota said, we've been able to scale both the backend DB calls as well as the server themselves.
Okay, any other questions? All right, let's have a big hand for Rayota and Robert.